Hello and welcome to mathematics. And I'd like to answer any questions. And as long as you have a Switch user, you can just post them in the chat. Yeah. Although I haven't actually gotten any questions, which is fair enough since I posted about this 3 hours ago. And that's why I'd like to just talk, really. Guess I'll do this and become big. Yeah. What's interesting? So I should probably tell something about myself. And I've studied maths for 1.5 years, something like that. I really like it, but and what's to like about it? That's, I suppose, the question. I'll talk about why maths is fun. The strength of mathematics, and and it sort of relates to the whole question of why do we need to learn this? Because let's be honest, it's one of the greatly asked questions. Why do we even bother about this? But I do think there's some things that gives mathematics value. Of course there is. Why would we be learning it if not? In short terms, the thing I think that makes maths great and what makes it really something worth learning is the ability to generalize. Because we don't really appreciate that, I don't think. Not very much, at least. How strong that actually is. These are 4 things. I'm down here in the corner. This corner, So mathematics allows us to think about these things, in a different way, because these are 4 lines, and they're not very interesting, really. But whereas if we took, for instance, 4 cows, they'd be more interesting. You can get food from them and stuff. But then the mathematics bit is thinking about it as a general thing. And we get a concept of just 4, and not 4 cows or 4 lines. When we have this general sort of thinking about something, we get certain abilities. Yes, for instance, we get the ability to add things, and and when we have 4 lines and we want to add 4 more lines, we don't actually have to draw them. Or if we have had 4 cows and someone gave us 4 more cows, we wouldn't have to, count them all to know there's 8. We just say, well, 4 plus 4, that's 8. Doesn't matter if it's lines or cows or, pencils, anything really. And this general way of thinking is it does a lot, I think. It makes us capable of a lot of things. And I'd like to talk about functions. Oh, this is the wrong button. Here we go. And you may have heard this before. Function is sort of like a machine. I do speak Danish, as you'd probably know. So, and I can answer in Danish as well. So, I want to draw a machine. Something like that, sure. That makes it up for a machine. You may have seen this picture before, if someone wanted to teach you about functions. So, and I think this is the way mathematicians, like actual professional mathematicians, not just everyone or me or anyone, thinks about it. It's sort of like this: something comes in and something comes out. This is the wrong way. Something comes in, something comes out. And usually, well, this doesn't look very mathematic, not very mathematic at all, but it actually is really mathematic. Or it has a lot of strength, yeah. And I think I'd like to write something over here. Oh shit! Just did this and that. Yeah. Usually we use this notation. The function of x. I can't really point at my screen. That doesn't make any sense. I'll just use this. The function of x equals something. It could be. Let's take an easy one. That's 3 times x plus something. Could be 7. Brilliant number. Yeah. So you'd probably be familiar with this sort of thing. You put something in. Well, this is just a linear function. I mean, I have no clue what your level is, but assuming you've finished, basic schooling, primary school, you would know this. You would maybe even by heart know functions of this kind. Yeah, of course there's many kinds of functions, but the important thing, and this goes for all of the more mathematical functions, is that it takes a number and a number comes out. So a number goes in, number comes out. And yeah, this is a machine really. And this is where I'd like to ask you questions, yeah. Because if I put in if I put in a number, let's use the proper f, the function of, let's say 3, yeah. This function, which is the one I've written over here, and what I'd asked was for the function of 3. That would make 9 plus 7, which would be 16. Yeah. So in this, I would like to call this a machine. And if you do not think this is terribly below your level, I'd like to ask you to consider this a machine that takes something in and puts something out. This specifically takes in an x and puts out a value, another, a y, which some would say, yeah, another number. So what mathematicians like to do, and this is where some of them like to see it like this. Yeah. So I like to these are the real numbers. Which basically means all numbers. And these are real numbers. So you go from the real numbers into the real numbers, the real numbers into the real numbers. Yeah. Then of course there's different types of functions that would go from, because not all functions go from the real numbers into the real numbers. For instance, if you did the square root function, this is where Paint will at some point eventually fail me, because a square root sign will not be easy. Yeah, tiny square root sign. Yeah, this function, for instance, would not go from the real numbers into the real numbers. No, it wouldn't. It would go from. This is where I like some more space. This function would go from. Yeah, you may have guessed it. The positive numbers. Because you can't take the square root of anything negative. It goes from... I'd like to use some notation here. I will. Yeah. I won't. Will I? Won't I? No, I won't. yeah, this is where it go. You can't take the square root, and I hope there's no one who's done imaginary numbers or complex numbers here, but and when you do take the square root of something, you can't get a negative number. Yeah. Like the square root of 16 is 4, and you couldn't. Yeah, you couldn't get a negative number. Well, some would say that you get both a negative and a positive number, but I mean, yeah, let's stick to the positive. Yeah. And in that case, it doesn't matter. We'll just change this to all real numbers, and yeah, it'll be pretty much the same. The point is that it goes from one set, is the proper mathematical term, into another set. Well, it's the same set, but you know, it's from one into the other. Now comes the thing where I make it unmathematical again, because this is somewhat mathematical. It's not the classic sense in which we think of it, but it's still it's still, yeah, proper maths. So oh yeah, function. Yeah, I had a 2T today, a guy, a tutor, and I talked to him about functions, and I tried to make this point that functions are not just functions of numbers; they could be functions of anything, because it's just a machine that changes something into something else. For instance, you could take a car washing machine. It's a machine that takes a car and does something to it and spits out another car. So you could say that it would go from not the realm of positive numbers to the realm of positive numbers, but you could say that it went from and this is where it gets, well, it's, I guess it's math. It's not the classical maths, but it's, you know, close enough. It goes from all cars, because I guess because you can wash all cars, from the realm of all cars into the realm of clean cars. Yeah, this is a function that takes in a car and spits out a car. You could do another one, yeah, because these are funny. You could do a car painting machine that would, oh, I guess that would again go from the realm of all red cars to let's say the realm of red, the realm of all cars into the realm of red cars, if it was a red one, yeah. Or it could paint them in random colors, and it'd be into the realm of green cars as well. Into the set of all red or green cars. Yeah. Interesting. Not a clue if it is, but I like it. This is linked to the mathematics that we learn, and I think it's linked to the reason why we learn mathematics. It's yeah, because this, like the numbers, are a way of generalizing things into an abstract thing. We can, in the same way, generalize functions. The brilliant example, of course, is the taxi. Is a great function because you get into the taxi. Costs, I don't know, 35. I'll be calculating in kroner for your information. 35 kroner just for the starting, and then it'll maybe be 5 kroner per kilometer. And yeah. And what's nice about maths is you can then generalize it, right? Is it 5 kroner times 5 times x plus 39. That will give us, if I just change this window, let's use these numbers. Yeah, this will, at least if you're able to see it, give us some, it'll give a function, yeah, because it allows us to think in general about what, you know, what a taxi ride would cost. Yeah. So, and you don't need to now I'll write it over here just so it's easier to read. Maybe you'll be used to the y notation. I use the f of x just because I like it. You can use them interchangeably. Never mind that. Yeah, you can use either. I just prefer this one. This is this function, yeah. And if you want to go x amount of kilometers, you just put in the amount, you know, and you get out however much it'll cost you. Yeah. Of course, the always funny thing to notice is that if you put in a 0, if you don't go anywhere, if you just get into the cab, it'll cost you. I've written 39. That's really stupid, since I'm pretty sure I did 35 over here. No, I did 39. I said 35. I did 39. Deal with it. Yeah, and this way of thinking is very applicable in other situations. If you're buying milk, if you're buying pretty much anything else. Yeah. Another good example is if you go into a bank and want to exchange your money, there'll be a starting fee. You have to pay something in order for them to even bother changing your money. I don't know how much. It might be 30 kroner, I think, here in Denmark. And then you'd get, for instance, you could change this 5 for a 7.5, and it'd be the exchange rate from kroner to euro, or whatever you like. And the nice thing about functions is, of course, that they could take minus values. This function takes minus values as well, and it doesn't make sense if you want to talk about a taxi, because you can't ride a taxi minus kilometers. But you could go into a bank wanting to. I'll just do it. Yeah, I'll do it. Never mind, I'll do it. This is the bank one. Let's say it's 30. That's not 30. This is 30. So this would be if you want to change from kroner into euro. This might be what the bank would cost. This is the price the bank will take from you, just in order to change it all. And this will be how many kroner you have to pay for each euro. Yeah. This is not to scale, of course. It goes up and down a little bit, but I don't care. I only like the maths bit of it. Yeah, but then if you went in there and wanted to get some kroner back, which would be minus x, you could then figure out how much money you'd have to pay them, how many euros you'd have to pay them. Because if I haven't done this wrongly, I'll just put it in here. I know this is hard to read, but I don't care, because it's just for my own sake. Still, that's bloody lucky. Nah, I don't want to draw it. Yeah, it looks almost the same. How very lucky. Yeah, in the basic school in Denmark, they say we learn maths. That's not true. We learn calculations. In gymnasium, at least in Denmark, or at college, university, you learn maths, proper maths. Because, and this comes back actually to the reason why we do maths in schools in general. It's not to be able to, it's not to get good at calculating. Because, I mean, sure, that was the argument some years ago, but we have our phones, we have calculators everywhere. We don't need that. What we need is their way of thinking. Yeah. It's sort of difficult, because you wouldn't, if you went down to the store to get milk, you wouldn't make up a function, 6.5 times x. You wouldn't actually make that function. But having the general thought of knowing that if I buy one more milk, that'll be the price of one milk added to the what I have already. And it doesn't matter if you have 20 liters of milk and buy the 21st liter of milk. It's gonna add the cost of one. It's not gonna add anything else. It's linear, isn't it? If you want to say it in math terms. And that sort of strict mindset is what's really useful in maths. That it's not gonna suddenly cost you 12 for the next liter of milk. It's gonna cost you the same as it always has, because it's a specific type of function. So if you just hold on to that, doesn't matter. You know, if someone comes adding an extra will give the same increase in price no matter how many you've already bought. That's the point. Yeah, the point I'm trying to make. The ability to think strictly about things and have this whole set of rules that is applicable to the real world. That's really the strength. Yeah, doing addition and subtraction and multiplication and division is so. It's so strong. It's so strong. Yeah, because it works, doesn't it? The natural numbers, the whole numbers, like 1, 2, 3, 4, 5, and the minus ones as well. They are so strong for describing the world. And I mean, of course, there's many very much more complicated parts of maths that describe even more of the world. But just that system is actually brilliant for describing a bunch of things. And I mean that's why it's been used throughout times pretty much. I think maths is the second oldest science or something like that. Oh well, I think that'll be it from me. I hope that it has been somewhat enjoyable.